Welcome back. In the last video, we added a capsule component, and we saw that just declaring a new uCapsule component pointer in our birds header file resulted in a compilation error. And we resolved this error by including the capsule component header file right there in bird.h. And I mentioned that this is not the best practice. So in this video, we're going to talk about why that is. Now imagine we have a class called creature. And in creature, we like a capsule component pointer. Now we know what will happen. The compiler will get angry and give us red squiggles here. And we saw that to get rid of those squiggles, we included the capsule component header file and the compiler was happy. Now what happens when we do this, however, is as soon as we compile, the preprocessor sees this include and goes and finds capsule component.h. And it literally replaces that include line with all of the contents of capsule component. Now, uCapsule component is a class defined here in capsule component.h, which means by the time the compiler reaches our variable, it sees that this type is defined. The problem with that is that capsule component.h contains all of the code in the capsule component class, as well as other includes that the capsule component header file needs, which means all of these include statements are added to creature.h, and the preprocessor goes and finds those header files and takes the code inside of those files and pastes it right here in creature.h. So creature.h has just become a great deal larger. Now the truth is that the compiler doesn't actually need to know all of those details just so we can have a capsule component pointer. The compiler really only needs to know the details about the capsule component, specifically how large it is, in certain situations. We need the size of capsule component when actually constructing an instance of the capsule component type. So the size of the class is important here. The size of the class is not important to simply create a pointer, as a pointer is designed to hold an address. So all pointers are the same size. Now this creature class has a constructor, and that's where we would actually construct a capsule component object using create default subobject. Now this action does require that we have the size information for the capsule component, so we can allocate that much space in memory. So if we could get away with not including the header file in creature.h and instead include it here, well then we're actually including the header where we need it. There's no getting around it here. We need capsule component to be defined in order to construct an object of this type. So what we can do instead in creature.h is as soon as we declare a new variable of type uCapsule component pointer, we can forward declare. This class keyword here means we're forward declaring the uCapsule component type. Now a forward declaration just means that we're declaring a class type without actually defining it. So we're telling the compiler that the uCapsule component type is not defined here in creature.h, but you can look for it elsewhere, wherever we use uCapsule component in a circumstance where we would need that information, such as creating a new object of this type. That's going to be in creature.cpp. So when we forward declare, uCapsule component is considered an incomplete type here in creature.h. An incomplete type being a type that describes an identifier, in our case uCapsule component is the identifier, without information needed to determine its size. The information that we would need to determine that class's size would be the class declaration itself. That would be in capsule component.h. So until the compiler can actually see where the uCapsule component class is defined, uCapsule component here is an incomplete type, and our usage of it is limited. We can only create a pointer of this type, but we can't do things like access member variables or functions, or create an actual object of this type. We don't have any of that information. All we know here is that this is a pointer. So here in creature.cpp, where we're actually creating an instance of the uCapsule component type, we'd get a compilation error as long as uCapsule component is an incomplete type. So how do we complete the type? Well, that's easy. We simply provide the definition for the class. And we do that by including the header file, as the class is defined in the header file. And once the preprocessor replaces this include line with the actual contents of that header file, this class type will be defined here in creature.cpp, and uCapsule component will no longer be an incomplete type. Now, you might be thinking, we're still including capsule component.h, so what's the difference if we're including it anyway? We can include it in the header file, and then we won't have to bother forward declaring with that class keyword, so it's really less work for us, right? Well, let's see what happens if we're in the habit of doing this all the time. Say we have a class called weapon. Now, weapon might need to include the header file for a class called mesh, which might be defined in mesh.h. It may also need a box component, so maybe it's including that as well. And perhaps weapons have a magic effect, and this class may be defined in magiceffect.h, so we're including all the header files that we need here, and now we can create variables of those types here in weapon.h. So far, so good. But then let's say we create a new class called inventory kit. And in inventory kit, we might need to use the weapon class. We may have weapon variables, right? So we may include weapon.h here. But because we're including weapon.h, the preprocessor is going to paste all the code in weapon.h, and it's going to see that weapon.h includes header files of its own. So it's going to go find those header files and paste their code in here as well. Now, inventorykit.h doesn't need mesh.h, it doesn't need box component, it doesn't need magic effect. It only needs the weapon class, as it's only going to have weapon variables. Now, on top of that, let's say inventory kit uses the armor class and the potion class. So it's including those header files. So inventory kit is getting quite large at compile time. But it gets worse. Let's say we have a warrior class. Now, warrior may have an inventory of its own. So if we want an inventory variable on the warrior class, say we include inventorykit.h in the warrior class. But that means we're going to get all the contents of inventorykit.h, which means we're including armor, potion, and weapon. And not only that, inventory kit includes the weapon header, which means we're getting mesh, box component, and magic effect. That's 6 new header files that we don't even need. The warrior just needs an inventory variable. It does not need all of the code in all these other header files. When the header files get large like this upon compilation, this is known as code bloat. And this can slow down compile times a great deal. So this is one reason why we should only include those header files where we actually need them. Now, instead, let's say we include our mesh, our box component, and our magic effect header files only in weapon.cpp, where we're going to use those types. Now, CPP files are not typically included anywhere. So we can use the weapon class in our inventory kit, and let's say we only include weapon.h in inventory kit. Now we're not getting mesh, box component, or magic effect included in the inventory kit header file. They're only included here in the CPP file where they're needed. Now, inventory kit can include armor and potion in its CPP file as well. So those are also not in inventorykit.h. So when we get to our warrior class, our warrior can forward declare inventory kit so that it doesn't need that header file in warrior.h. We can simply include it in warrior.cpp. And by doing so, we only get the code in inventorykit.h, which does not include mesh, box component, or magic effect. On top of that, it doesn't include armor or potion. So we're only including a single header file for inventory kit without all the other code that we didn't even need to use in warrior. So this is a great reason for forward declaring and only including header files where we actually need to use them in CPP files. There's another reason for forward declaring. It has to do with circular dependencies. Let's say we have a class weapon.h, which needs to include warrior.h. And then we might have another class called warrior.h, which needs to include weapon.h. Now, if we did this, we'd get a compiler warning. The compiler would complain that it's detected a circular dependency. These two header files depend on each other, and this is not really possible to do. How can you include weapon.h, which includes warrior.h? The preprocessor doesn't know how to handle this. It would see warrior.h, find that file, and include it here in weapon.h, but then it would find that warrior.h requires weapon.h. So it would go back and find weapon.h, which needs warrior.h, which needs weapon.h, and we have this infinite loop that cannot be accomplished. So circular dependencies are not good. And if we're in the habit of including headers in other headers, circular dependencies can happen. So this is yet another reason to forward declare and only include the header files we need in the CPP files where we use those types. Now the solution to this is simple. All we do is include warrior.h in weapon.cpp. Weapon.cpp isn't going to be included anywhere, so we don't have the risk of circular dependencies. Likewise, we include weapon.h in warrior.cpp. This is totally fine. We can include warrior.h in weapon.cpp because warrior.h does not include weapon.h. We place that include in warrior.cpp, which is not being included anywhere. So this prevents circular dependencies, and this will compile just fine. Now, it helps to know when we need to include header files. We must include header files when inheriting from a parent class. So that's why you do sometimes see header files included in other header files. Hopping back into the editor, we see that our bird class inherits from the pawn class. Now, we can't possibly inherit from pawn without having details of the pawn, such as its size and its member functions and variables. So that's why Unreal Engine provided this header file automatically when it generated the class. So inheritance does require that we include the header file here in another header file. Now, you also see core minimal and the .generated.h file. These are also needed, hence why they're automatically included, as there are some types that we need in core minimal. So we're including it here. And you will notice that core minimal is included in lots of different files. You'll see it here in item.h as well, all the way up here at the top. Now, we won't get a circular dependency because core minimal contains lots of basic information that we can include in all of these header files, and we'll never include it twice because it contains its own pragma once. And if you don't know what pragma once is, it's a guard that prevents us from including the same header file twice anywhere. So if I included item.h somewhere else twice, pragma once will recognize that and only include it once. So we know that we need a header file for a class inside the header in which we're inheriting from that class. We also need the header when we need the type size, as we saw with creating instances of that class. So using a factory to construct an instance of the class requires that we have that header file included for the class. We also need the header file for a class if we plan on accessing member variables and functions from that class. So it can't be an incomplete type if we're accessing variables and functions from it, as that information is included in that class's header file. That's why we declare functions and variables in header files. So we'll be making use of these best practices throughout this course, only including header files where we need them. And we'll start with our capsule component. So we'll go back to bird.h, and instead of including capsule component here in bird.h, we're going to cut that out. So I'm going to copy it and delete it and head over to bird.cpp and include it here instead. Now that it's included here, we can construct a new capsule component using create default subobject. But remember, as soon as we remove the header file from bird.h, we had that compiler error, which means we need to forward declare the uCapsule component type here. Now, if we do that, we can go ahead and compile. Once again, I'm going to close out of the editor first, and from here in Visual Studio, I'm going to hit Control-B to build this. And I have a successful compile. So we've successfully forward declared a class. Now, once you've forward declared a particular class type, you can then use it from that point on in the header file. So if I created another uCapsule component pointer called second capsule, you'll see that I don't get any compiler errors. And this does compile just fine. That's because the compiler already knows that this type has been forward declared. But if I try to, say, declare this variable up above the forward declaration, right here, I would get a compiler error because it hasn't been forward declared yet. And the compiler goes through this file line by line, starting at the top. So by the time it reaches this line here, it's not going to know what this type is. If I hit Control B here, then I get compiler errors. And these look like the errors that we've already seen. So for that reason, some people like to forward declare classes they're using all the way at the top of the header file, just under all the includes. So we can do that instead. Here's how we do it. Right here above the class, it can be outside the class, that's fine. We can forward declare uCapsule component here. So we say class uCapsule component with a semicolon. Now this class has been forward declared and we can use it anywhere down here. I can remove the class keyword from our variable, and if I hit Control B to build, I have a successful compile. So forward declaring all the way up at the top means we can use that type anywhere. So some people like to forward declare on the same line where they declare the variable like we first did. Other people like to forward declare up here at the top, and they just keep all their forward declares right here in a nice little list, and that way they can use that type freely throughout the header file. Both methods are legitimate. I'll go ahead and leave our forward declaration here at the top for our capsule component variable. And I no longer need this second capsule as I just created it for demonstration purposes. So now that we've forward declared our capsule here at the top, we're not including the header file here as we don't need it simply to create a pointer variable. We're including the header file in the CPP file where we do need it to construct an actual capsule component. And this is better programming practice. Now, you might be wondering why we didn't have to forward declare the static mesh component type for our pointer variable here in item.h. We didn't forward declare it, and we didn't include its type at the top, and yet we didn't get any compiler errors. Well, the uStaticMesh component type is already included by default. Our item class is based on actor, and actor does include header files in its header file, actor.h. And the actor.h header file includes some header files of its own, and some of those include header files, and somewhere up the line, the static mesh component is already included or forward declared, so we don't need to forward declare uStaticMesh components in actor classes. So if you ever get a compiler error for having an undefined type, then you probably need to forward declare. And if you're not sure, it's always safe to just forward declare anyway, and just include that header file where you need it in the CPP file. But in our case, we could compile without including static mesh component, so we're safe here. But in the capsule component case, we did have to forward declare, so we have that here. Great job. I'll see you in the next video.